The functional group of esters is like this, which is different to the carboxylic acid and carbonic compounds. So the functional group of esters is COO. Now, in order to name the methanol, in order to name the esters, there is some differences while naming the, actually in terms of naming the esters. Okay, here you can see this is the COO, right? And in this part, in the right hand side of the ester, there is only one carbon, right? That's why we are saying as methyl methanoate. And there is also one carbon. So in the ester, in the COO group part, there is only one carbon, and in the methyl part, there is only one methyl group. That's why we have seen it as methyl methanoate. But here, what you will see is in the COO group, in the left hand side, there is one methyl, so we have written methyl. But here there is one carbon, two carbon, so that's why we have written methyl ethanoate. The COO is bonded with another carbon, that's what we are saying is methyl ethanoate. Here what you guys will see is this COO is bonded with two carbon atoms on the left hand side, on the right hand side. That's why it is ethyl. But this carbon is bonded with only one carbon. No more carbon. It is not bonded with any more carbon. So it is methanoate. Here in this COO group, you can see on the right hand side there is two carbon. So it is ethyl. And there is also two carbon in this part as well. So it is ethyl ethanoate. Now here in this 2COO group, on the left hand side there is only one carbon along with the COO, so it is ethanoate. But on the right hand side there is 1 2 3, there is three carbons, so it is propyl ethanoate. So the number of methyl groups are also important. The number of methyl groups will give us the propyl, ethyl, methyl, and the COO, which is bonded with any other carbon, will give us ethanoate, methanoate, or anything else. So this is how you will have to understand the esters. Now moving on to the esterification of the esters. Okay, now moving on to the esterification. So almost equal amounts of carboxylic acid and alcohols are taken in a dry test tube, and a few drops of concentrated sulfuric acid are added to it. Okay, the mixture is warmed for a few minutes in a water bath and then poured into Na2CO3 solution. So how does it actually work? How does it actually work? Let's say this is a dry test tubes where there is dilute Na2CO3 solution, and in this solution what we will do is you will pour this mixture. Which mixture? The mixture containing carboxylic acid, alcohol, and concentrated sulfuric acid, few drops of concentrated sulfuric acid. When you will drop this mixture into dilute Na2CO3 solution, there will be something that will actually form. There will be a formation of effervescence. Effervescence will form due to the formation of carbon dioxide. Carbon dioxide will form. That's why some effervescence will also form. And an oily liquid floats over the Na2CO3 solution. So an oily liquid, let's say, over the Na2CO3 solution, there will be a little bit of oily liquid that will form. So this oily liquid is which will form in the Na2CO3 reaction. And this oily liquid is the ester, which has a fruity smell, or the smell of nail polish, actually, not alcohol, which has a smell of nail polish. Okay, this is something with which girls are more familiar with, the smell of nail polish. So basically the mixture can be formed using alcohols and carboxylic acid of same quantity or equal amount, and a few drops of concentrated sulfuric acid will be added with these two, and then the mixture will be warmed in a hot water bath and then poured into Na2CO3 solution, which will show effervescence due to the formation of carbon dioxide, and then later on an oily liquid will float over the Na2CO3 solution. This oily liquid is known as the ester. This is the ester, which will have a smell of fruit or nail polish. So basically, if we name this part, we know this is COO, right? On the right hand side of COO, there is two carbon, so we can say it is ethyl. And as this COO is bonded with only one carbon, no more carbon, so it is ethyl methanoate, right? So this is how we actually name them. Now moving forward, we will learn about the acid hydrolysis of esters and the alkaline hydrolysis. So what is actually acid hydrolysis? Acid hydrolysis means the ester reacts with water in the presence of acid and it will form a carboxylic acid. The ester will react with water in the presence of carboxylic acid. Sorry, the ester will react with water and form carboxylic acid and alcohol. This will form carboxylic acid and alcohol. This is actually a reversible reaction. You can also react carboxylic acid with alcohol to form an ester. Okay, this is a reversible reaction actually. So this reaction is reversible and exists in equilibrium. It will exist in equilibrium. The condition is heat under reflux. This is what acid hydrolysis is. Now moving forward to the alkaline hydrolysis, the reagent required is sodium hydroxide or potassium hydroxide and the condition will be heat under reflux. So here you will react the ester with sodium hydroxide and it will form salt of carboxylic acid. It will form a salt of carboxylic acid with which to get the final organic product we will have to react with an acid to get the final carboxylic acid. So the hydrolysis with aqueous alkali is not reversible. As this is carried out in alkaline solution, it is not a reversible reaction. Okay, as this is not a reversible reaction, it produces a good yield of the salt of the carboxylic acid. A good yield is formed. Let's say if something is formed into product of 50 cm cube, it will never ever get back it will never ever um, get back into reactant and become 45 cm cube, which happens for acid hydrolysis because it is reversible. If the product formed is 50 cm cube, it can anytime become 45 by reversing into reactant. The product can become reactant, but here the product which has formed will remain as a product, so the yield is greater. So a good yield of carboxylic acid salt is formed and alcohol as well. Both of them are the product, right? The salt of carboxylic acid and alcohol, both of them are product. If the organic acid is required, the solution is cooled and excess dilute strong acid such as HCl and H2O is added. When you add HCl or HCl of dilute HCl or H2SO4, this salt of carboxylic acid converts into the raw carboxylic acid. Okay. Now we have to understand about the saponification as well. Saponification is something by the way we actually produce soap. This is more or less very common in our daily to daily lifestyle because we all bath using soaps, right? So basically soap is produced by the alkaline hydrolysis of triglycerides. This is a triglyceride. This is a triglyceride. This is a triglyceride. Okay, this is a triglyceride, and so basically soap is produced by the alkaline hydrolysis of triglycerides formed naturally in animals, plants and vegetables. A triglyceride is an ester of a long chain carboxylic acid and a triol. So this triglyceride is a long chain carboxylic acid and triol. So which one is the carboxylic acid and which one is the triol? So let's look after this part right now. Now here this particular part of this smaller part is the alcohol. If you take this smaller part right here, this is the alcohol part, and if you take this smaller part, this is actually the triol part. This one is the carboxylic acid and this one is the triol or alcohol actually. Basically you don't need to understand about which part is which one, you just need to understand that triglyceride is an ester of long chain carboxylic acid and a triol. When you react carboxylic acid and triol or an alcohol, it forms an ester and the name of that ester is triglycerides. And when you react this triglyceride with sodium hydroxide, which is an alkaline hydrolysis, it forms or it breaks down into glycerol and sodium stearate. Okay, it forms into sodium stearate, which is carboxylic acid and alcohol. Sorry, carboxylic acid and alcohol. This is the alcohol part and this is the carboxylic acid part. Just like here, when we did the alkaline hydrolysis, we produced a carboxylic acid and an alcohol. Okay, this is what happens for the soap as well. So make sure to remember the whole equation, each and every part of it, memorize them and understand how the reaction occurs actually You just need to understand that the saponification of saponification is an alkaline hydrolysis which reacts esters such as triglycerides with sodium hydroxide and then forms an alcohol and a carboxylic acid. And the name of that carboxylic acid or the salt of carboxylic acid is the sodium stearate soap, which is sodium stearate. This sodium stearate is very important to understand. And one thing, this is the salt of carboxylic acid, not a carboxylic acid. This salt of carboxylic acid needs to be reacted with dilute HCl or dilute H2SO4 to obtain the final organic product as carboxylic acid. Okay, so this is the complete end of the esters. Moving on to the acyl chloride part, just like esters and carboxylic acids,